Good morning all. Today we are going to discuss about derivation of one-dimensional heat equation. We derive one-dimensional heat equation which is due to the flow of heat or a heat flow along a thin bar or a rod insulated on all sides. We have the following empirical laws which has to be remembered. Heat flows from a higher temperature to the lower temperature, and the second point is the amount of heat in a body is proportional to its mass and temperature. The third point we need to remember here is the rate of heat flow across an area is proportional to the area and to the temperature gradient normal to the area, where the constant of proportionality is called as the thermal conductivity. So this is the 3 points or the empirical laws based on the observation or experiment in the respect of heat flow. We need to remember the 3 points before going for the derivation. Here is the diagram. The x-axis, heat flow is in the x-axis, and this is a point we have taken x, and then the small distance, that is delta x or a dx, x plus dx, and the length of this is L we have taken here. From this point to this point we have taken. Now consider the heat conducting homogeneous rod of length L placed along the x-axis. One end of the rod at x is equals to 0. You can see here one end of the rod is at the x is equals to 0, this point, and another end at this point. So x plus delta x we will be taking it. So x is equals to 0 and the other end at x is equals to L, and assume that the rod has a constant density rho and the uniform across the section A. Also assume that the rod is insulated laterally and therefore heat flows only in the x direction. And let x with the temperature of the cross section at the point x and at any time t, the thermal conductivity of K of the material of rod on the temperature gradient dou u by dou x. And the next thing is the Q1. It is the quantity of heat flowing in the cross section at the distance x in the unit time. That is, Q1 is equals to minus Ka into dou u by dou x at x, and Qx is the quantity of heat. Flowing out of the cross section at the distance x plus delta x, Q2 is Ka into dou u by dou x of x plus Vx, and Q1 minus of Q2 will be minus Ka into dou u by dou x of x plus Ka into dou u by dou x of x plus delta x. The same like the wave equation what we have done. This is our Q1 and Q2. This is the Q2. So Q1 minus of Q2, if we take Ka times of dou u by dou x at x plus Ka times of dou u by dou x at x plus delta x. So that I have explained already. Q1 minus Q2, let us simplify this by taking the Ka outside, and let me write the positive term first, that is dou u by dou x at x plus delta x, which is written as a positive term first, minus dou u by dou x at x. Hope you can understand this. Q1 minus Q2 we have done, and this is what we have got it. And when we take this Ka outside, which is common, and we will be getting the positive term first, that is dou u by dou x of x plus delta x minus dou u by dou x at x. Let us call this as equation number 1. Now, but the rate of increase of heat in the rod, if we take, it is rho a s into rho a del dx is equal to dou u by dou t. That is, Q1 minus Q2 is equals to, because dou u by dou t is that, S into rho A dou x dou u by dou t. Rho is the specific heat. S is the specific heat and rho is the density of the material. Now, S specific heat into density of the material into area of cross section into Vx dou u by dou t is given by Ka into dou u by dou x x plus delta x minus dou u by dou x of x. Next we have S into rho divided by K. Let us take this K outside and then it is into dou u by dou t is equal to, let us divide by delta x to take the limits. Dou u by dou x of x plus delta x minus dou u by dou x of x, and this gives us when you take the limit as delta x tends to 0, we get this result, that is S into rho by k into dou u by dou t delta u by delta t is equals to dou square u by dou x square, because delta x is the change of variable. Or we can simply say dou u by dou t is, on taking this k to the right hand side and s comma s rho to the denominator, s rho divided by k to the right hand side, if we take it is k divided by s into rho del square u or dou square u by dou x square. That gives us dou u by dou t is equals to c square of dou square u by dou x square, where we are taking this constant term, that is k divided by s into rho, as our c square as a constant. This is going to be the derivation of heat equation. Thank you. So, in the next class, I will be discussing about how to find a solution of both heat equation as well as wave equation.